Hello and welcome back to Mastering Statistics. Here we're going to get our hands dirty just a little bit and start talking about the F distribution, but talking about the tables that you're going to use to solve every one of these problems. Now it does get a tiny bit confusing because unlike some of the other distributions, the F distribution is actually a whole series of tables. So you're going to have many pages in the back of your book and it's tough in the beginning to figure out what you need to do or which table to use. So I'm going to try to break it down for you. In order for you to understand this, I need you to keep this mental image in your head. All right, we have this idea of the F distribution. I'm going to sketch it over here for you so that you can kind of have it in your head. It kind of is lopsided. It goes up and then it's very much skewed like this. So this is the values of F along this axis. We start at 0 and then we go 1, 2, 3, 4, 5 and so on up to infinity like this. And so the distribution never really ends. It just kind of approaches the axis like this. And it's always skewed to the right like this. All right, now the thing is that when you're using the tables in the back of the book, you're really going to be trying to find what we call a critical value. And that critical value for these types of problems, for the hypothesis testing problems we're going to do, is called F sub alpha. And F sub alpha is just a value of F off of that table. And it's the special value of F that has as its area to the right-hand side under this curve the value of alpha, which is the level of significance. So for your problem, you might have a 90% level of confidence. Remember, level of confidence is C. 1 minus C is a level of significance that's what we call alpha. So typical values of alpha might be 0.1. That would correspond to 90% level of confidence. Level of significance might be 0.05. You take 1 minus 0.05, you're going to get 95% level of confidence, and so on. So typically you're doing 90% level of confidence, 95% or 99% level of confidence. So the most common values of alpha that you're going to see in these problems that you're really doing is going to be 0.05, 0.10, and then 0.01. Because this one, when you take 1 minus this, it's going to correspond to 0.95, which is 95% level of confidence. 1 minus this is going to be 90% level of confidence. 1 minus this is going to be 99 level of confidence. There's no point in statistics in doing a problem with 70% level of confidence. It's worthless. So you're always going to see values of alpha that are going to be pretty much these three values there. So when you're trying to use these tables, you're really just trying to read the value of F off the table that gives you your level of significance, which is the shaded area under the right. So depending on what value you have here, you're going to have a different value of F to give you the shaded region. But the trick is that this entire curve depends on alpha, the level of significance for your problem. It also depends on how many people you sampled. That's what we call the degree of freedom. But in this case, since you have two variances, you have a degree of freedom of the numerator and a degree of freedom of the denominator. Let me refresh your memory on that. The test statistic that we're going to use to determine if we reject or fail to reject is going to be the ratio of population 1 and their measurement variance, or I should say sample variance, and population 2 sample variance, right? So that's what we call in the tables. You're going to see numerator and denominator. This is the numerator they're talking about, the denominator that they're talking about. From this, or this sample variance that you got came from N1 samples, and this guy came from N2 samples. Right. So the bottom line is, and I'm going to show you a chart here in just a second, the bottom line is we're going to show you a table in just a second, and you're going to have to know how many samples you drew from population 1, how many samples you drew from population 2, and then we're going to be using that to read off the values. So let me just show you what a typical F distribution table looks like. So here's the first one, and I'm going to kind of pull down here for you. And yours is going to look different for sure. The number of decimals that you have in your table and exactly how it's set up is going to be different depending on how your book is set up. This is just one of them. So this tells you F values for alpha 0.01. Okay, notice that it goes 1, 2, 3, 4, 5, 6, 7, 8, 9 along the top, and then it goes way down here, and I can drag the table up so you can see the bottom. It goes down really far. What you're looking at here is a table of values of F. You read values of F off the table. F sub alpha is what you're trying to read out of here. It's going to be one of these values. And notice that this is for alpha 0.01. So that means that every value here that you pull out of here is going to give you an area to the right, a level of significance of 0.01. So if you were doing a problem with a